Today we're in section 6.4. We're covering the percent of change. This is percent of increase and decrease. So we're going to start trying to form some habits here in how we write our answers. You'll see a lot of similarities between the examples. The first thing we need to understand is our formula. This is our basis. This is our starting point. So we have the top one, which basically explains what each piece of the formula means. Okay, percent of change equals the amount of change between the two values. This value is never negative. It's just simply the difference between the two. It doesn't matter on the order, okay? The way I abbreviate it, don't you love abbreviations when it kind of shortens it up? You don't have to write all the words out. P stands for percent of change. AOC, amount of change. ORG, original, okay? So I'm dividing the amount of change by the original amount. So let's look at example 1. I have a table of values. It shows the number of hours you spent online last weekend. What is the percent of change in your time spent online from Saturday to Sunday? All right, so there it gives me a starting point. Saturday is my starting point. So P equals the amount of change, okay, we're always going to start with our formula, divided by the original amount. Okay, so what is the amount of change? 4.5 minus 2. And I don't mind if you use mental math here to go ahead and do this subtraction. What's 4.5 minus 2? 2.5. 2.5. And I would divide it by the original amount. So according to my order, from Saturday to Sunday, Saturday is the original. And what was my value for Saturday? 2. Okay, so you just said that means 2.5 divided by 2. Okay, I don't mind if you skip right to that step and you don't write the subtraction. Okay, we can do that part mental math. What's 2.5 divided by 2? 1.25. Not 1.25. I thought it was just 1.5. 2.5 divided by 2. Oh, it is 1.25. Okay, so 1.25. Now, in my formula, just like we learned yesterday, there's nothing in my formula that converts the decimal to a percentage, which means I have to do it. Okay? So this is a decimal value, but the problem specifically asked for the percent of change. So what is 1.25 as a percent? Yes, 125%. Now, the last question I'm going to answer, all right, and this is not going to be like spelled out for you on a quiz or test. You will have to look at the values from the original value to the new value. Is that an increase in values or a decrease? It's an increase. So you can write INC, not in highlighter. Okay, INC for increase. We will always specify whether it's an increase or a decrease. Okay, so apparently I had a little more time on my hands on Sunday. Okay, versus Saturday. Maybe Saturday was chores all day or something. Okay. All right. Okay, let's look at the next slide. All right, now this is just a real straightforward, here's the information, okay? From 10 inches to 25 inches, I don't even know the scenario. I kind of like to know, like, is this, what is growth? Is it like a tree or what is it? But from 10 inches to 25 inches, okay, I'm going to use my formula, P equals AOC over ORG. And we're going to do this repetitive writing of our formula to help us memorize it. We know that the more we write it, we'll just have it memorized. It just kind of becomes ingrained. So what is the amount of change between the two values? Again, it's not negative or positive. It's just what is the amount of change between the two? 15. What is it, guys? It's 15. So 15 would go in my numerator divided by the original amount. What's the original amount? 10. Okay. Now I must change this to a decimal. 15 divided by 10. That's the 1.5. I knew there was 1.5 in here somewhere. Okay, but is this a percentage? No. What is my percentage? 150. Yes, 150%. Now, from the original to the new, is it an increase or a decrease? It's an increase. Okay, so INC for increase. All right, go ahead and try this. What now? Yes, calculators are allowed. Go ahead and try the second one. If it's a long decimal, go out 4 decimal places. Okay, we're about to come up on some of those. I can't remember if it was this one, but whenever it's a long decimal, we'll go out 4 decimal places and then change to a percent. Okay, so did you get 8p equals 8 divided by 57?
Yes.
Okay, and it was a real long decimal, 0.1403. 0.1403. Okay, so now I use this 4th digit to round the 3rd digit. Okay, so does the 3 do anything to the 0? No. Okay, so when I change it to a percent, it becomes just 14.0 or just 14%. Okay, now because I rounded, I'm going to use the little approximation symbol. Approximately a 14% increase because I rounded that decimal. So anytime you round your answer, just do the approximation, which is a squiggly equal sign. All right, next example. Okay, so now look at the bar graph. All right, what's my category here? What's this all about? Softball. Okay, what's my vertical axis? Seasons. What's my horizontal axis? Home runs. Okay, so what percent of change in home runs occurred from 2016 to 2017? So I'm going to use my formula. P equals AOC over ORG. So what am I going to subtract in my numerator?
Your home run.
Yeah, which is what numbers? 16 and 17. What numbers would I subtract? 28 and 20, guys. Okay, do you see where we got those two numbers?
Yeah.
The percent of change is subtracting these values, the original and the new. All right, Samuel? Okay. All right, 28 minus 20. What do I divide it by?
28.
The original amount. Do you see how it says from 2016?
Yes.
Okay, so that's the original amount. That's why I divide it by 28. Now, if you just start off by writing it this way, 8 over 28, that's fine. If you do that subtraction in your head. All right, is anybody confused on how I got 28 minus 20? You don't see where I got that? Okay.
Write that out.
You don't have to write, you can just subtract in your head, but I have a couple people where I feel like you're getting confused on that. Matthew?
28 was your original number, so you subtract 28 from 20.
But it's never negative. You're just subtracting the two numbers from each other. Okay? What you divide by is the original amount. Okay? Your numerator cannot be negative. Okay? You can't have a negative percent of change. All right? So you're just subtracting the two numbers from each other. It doesn't matter which one comes first. All right? So 8 divided by 28. We've got kind of a long decimal. Again, I got 0.2857. Okay? So now the 7 does round the 5 to a what?
6.
To a 6. Okay? 28.6%. I would rather you leave it 28.6 if you did it to 29. Last year I took off like a point for that. But again, I'm really not overly concerned about the rounding part. I mean, it might be a point at best. Okay, so I do want you to go out 4 decimal places and round to the 3rd though. So let's just all kind of try to stay on that track. All right, last example. Something called percent error. You need one more formula, and I apologize because I somehow left this off your notes. So let's write it in together. The formula for percent error, we're going to call it PE for percent error, okay, is the amount of error. So how much is it off by, divided by, I like to say like the goal amount or what it was supposed to be. Okay, your book says actual, but actual to me throws it off because is it what actually was put in there? That's not right. Okay, So we're going to say it's over the goal amount, what's supposed to be there. All right, does that make sense?
Yes.
Okay, so now let's read this scenario. Before we read the scenario, all right, I'm going to try to help you guys relate to this problem. How many of you have ever opened a bag of chips and you thought there's a lot in here, and then you open it up and half of it is full of air?
Yes.
Okay, all right, so I'm hitting a relatable topic here. Okay, so now 50 years ago, people were the ones kind of filling boxes and filling bags. Those were people doing it, and there was percent of error there, right? Well, now we know these days it's machines for the most part, because machines have a very small percent of error. Imagine you work for this dog treat company, and you're like, man, I'm feeling good today. I'm just going to put as much as I can in these bags. And yeah, these people deserve a lot of treats in their bags, and I just fill it up to the top when it's supposed to be like 16 ounces per bag. All right, who's losing money?
You.
The company or the customer? If I'm stuffing it full and it's supposed to be only half full, the company is losing money. So percent error, especially in like a manufacturing type of scenario, is very important. We want that number as small as possible. We want the customer to get what they paid for. If they're paying for 16 ounces, we want them to get 16 ounces. Okay? Now, if they're paying for 16 ounces and I send them their package and they only have 14 ounces, who's getting ripped off? Yes. Okay?
2 ounces.
So let's get into the problem. You fill bags with about 16 ounces of homemade dog treats. Okay, so that's the goal. All right, now the acceptable percent error when filling a bag is 5%. All right, so if your boss is saying, hey, like 5% is the max, otherwise you're, going to be in trouble. All right, so we're weighing the bags. We're going through and we're weighing the bags. Bag A is 15 ounces. I need to know if that is within the percent error. Here's how I do it. How much is it off? Okay, so bag A, PE equals the amount of error. That's my goal, subtracting what actually is in there. Okay, I need to know how much it's off by, divided by the goal amount, 16. Okay, so the difference is 1. Oh, that's not too big of a deal. Well, we'll see. What's 1 divided by 16?
0.6.
PE equals 0.0625. So what is that as a percentage?
6.3%.
6.3 or just 6.25%? Okay. Okay, so is this acceptable?
No.
No.
You're fired.
He's fired. Who said fired? That's what I was about to say. He's fired. Oh no. Okay, so what about bag B now? Okay, so on bag B, let's calculate it. Percent of error. Now, guys, listen. 16.5 minus 16 divided by my goal is 16. So now it's only 0.5. But I still don't know. I have to test it. I mean, it looks like it might be okay. Divided by 16. Now my percent error, okay, is approximately 3.13%. All right, you see that? It's like 0.03125.
That's the favorite title.
So is this person okay?
Yeah.
All right, so they're getting a raise.
The other kid's getting manager now.
Okay, very good. All right, so this employee can be trusted. Okay, do you see how we calculate percent error? This is on your quiz and it's on your test. Any questions? All right, so that'll wrap it up for 6.4.